Steve, you are an experienced polyglot, full-stack software engineer. You've worked on everything from video conferencing software to GPS satellites, and you now work as the .NET developer advocate for Redis. We are so happy to have you here.
Thanks. Yeah, so I guess I should just kick it off then. Is that all right?
Yeah, please do.
Cool. I think folks should be able to see my screen. I haven't actually used this feature in Teams yet, so it's interesting for me.
Yeah,
but anyway, hello. Like Lee said, I'm Steve Lorello. I am a developer advocate at Redis, and I'm going to be talking to you today about indexing, searching, and aggregation in Redis using RediSearch and .NET. So a little bit of an agenda. I like to usually give agendas before I start a talk. I think it makes it a little more coherent. Just going to do a quick introduction to what Redis is. A little introduction to some of the Redis data structures that are pertinent for storing data and retrieving it via an index. Just a very brief touch on what a secondary index is. And then we'll look at actually building secondary indices. We'll look at building secondary indices using any form of Redis. And then we'll be looking at using secondary indices using Redis search. And then writing queries for Redis, writing aggregations for Redis. And if we have time at the end, I might be able to show you a little bit of what we have in the pipeline at Redis to make this stuff even easier. So let's start off. What is Redis? I suspect a fair number of people have heard of Redis before, but if you haven't, that's all right. It's a NoSQL database. It's an in-memory database, completely in memory. There are deployments of it that you can push on the flash disks, but essentially it's meant to be an in-memory database. Fundamentally, it's a key value store. You get a key, you go to Redis, you hand it the key, it gives you a value back. But in addition to that, it has other data structures, which still makes it a multimodal database. And between its key value store and in-memory architecture, it is blazingly fast, and that speed and its relative simplicity to use, it's mostly used off of a command level interface, has made it extremely popular. I think the Stack Overflow database survey basically put of the NoSQL databases, Redis is the most beloved. Just a couple weeks ago, actually. So I guess this is gonna. I must have chopped a slide off somewhere. But anyway, this is gonna pop right into some of the data structures. I must have messed up my slides. That's all right. So I'm going to talk about some of the data structures first. The first and probably the simplest is a string. So a string in Redis is essentially just a value that's stored in Redis as a string. So you can essentially do like set foo var, and then you can get foo back, right? So like it's actually just a string that you're storing at a value in Redis. Strings can also be numeric, so I can set num to 1, and then I can incur num, and that increments it to 2. So strings allow you to essentially store data at a particular key in Redis. It lets you expire them. It lets you set time to live on them. But essentially, it's the most simple data structure in Redis. It's actually pretty much the building block of all the data structures that we use in Redis. So moving on from there is the set data structure. A set is a set of unordered strings in Redis. It's just like a mathematical set. It allows you to store essentially strings with no order and with no duplication. And what's nice about them is they enable you to essentially have unordered sets and also perform set operations at the end. So like if I wanted to run like, so if I do like sadd, I know it says sad, my set foo var baz, I can do like an s members and get all the members of my set. And then I can do sadd my set foo again and again and again and again and again. And at the end of the day, there's just one foo left in here. And if I want to do like a union or an intersection or something like that, I can do like an sadd my set 2 bar and baz, and I can run set operations on this. So like I can do like a sinter, which is set intersect, my set and my set 2. And that lets me essentially pull the intersection of these two sets. If I want to do a union, so S union, my set and my set 2, it's just going to be the original my set because my set 2 is just a subset of the set. So what's nice about sets is that they allow you to have mathematical set operations. They don't care about duplication. They don't let you duplicate stuff in them, and they're relatively quick to look things up in. Or they're very quick to look things up in. Oh, you see, here it is. So my thing got misordered. So I have strings, sets, sorted sets, which we're going to talk about next, hashes, and JSON. And of course, there's my string slide. A sorted set is just like a regular set, except it is ordered. Essentially, you insert score and member pairs into a set. Again, it doesn't allow duplicate members. And if you add a duplicate member with a different score or even the same score, it'll combine the scores together with, you essentially tell it how to combine them. You could do like min, max, sum, maybe I think average might be one of them. Essentially, it lets you combine different members in the set together. And they can be ordered either by score, what their rank is in the set, or lexicographically. So if two items have the same score, it essentially lets you order them lexicographically too. So if I wanted to like say z add person age, so like a little preview of where we're going with this, I'm going to be showing you how to build an index for a person. And I want to say 32 Steve, 0 for Dustin, my son. I can then do something like a z range by score, and then I can say person age, and I could say I want the minimum to be -1 and the maximum to be 30. So anyone who's between -1 and 30 or -inf and 30. Right? And you could reverse that too. So I could do 1 to 33 or something like that and just get myself back. Essentially what makes sorted sets so nice is they provide you a relatively easy interface to order things in Redis and get them back. And we'll get to like what this means in a little bit. Redis hashes are essentially a field value store in Redis. And it's actually where storing objects in Redis starts to become possible, right? So like if you wanted to store something in a string, you could store like JSON or some sort of encoded string in Redis, but then every time you want to get that thing, you have to pull back and set the whole thing over and over again. What hashes allow you to do, and what JSON, which is the next structure we're going to talk about, allows you to do, is it allows you to store objects in Redis. So essentially you store them as field names as strings and field values as strings. So like person 1, for example, might have the age of 32 and the first name of Steve. And so if I did like an age set person 1, first name of Steve and age of 32 and age set person first name Justin and age of 0. I can do like an hget person 1 first name, and I can get myself my name back. And if I want to just change that, because maybe I changed my first name to Bob for some reason, I don't know why I would do that, but if I changed it to Bob for some reason, I could just set that single field in there. And that actually is what lets us get into storing objects in Redis. Next data structure is a newer data structure. It's JSON. You can store objects as JSON in Redis, and you can access and update them via the JSON path to it. This is a Redis module, so it's essentially a plugin to Redis, and it's available. Unlike the rest of Redis, which is available under open source license, pure like BSD2 license, this is available under what's called a source available license. So as long as you're not a cloud provider, so AWS can't spin up a version of this, Azure can, yeah, like the cloud providers, they can't essentially use this in a SaaS product, but you can just use it as for free as a developer. But yeah, so you can do things like JSON.set. In person one, you can pass in that object. So if I do a flush, and I do a JSON.person:1, you have to give it the path, which I'm putting as the root path, and then I can. I always have to remember what the correct age. And if I wanted to do a get on this, I can just do JSON.get person:1. I can do a name, right? And that gets back the name. Again, yeah. So that's another data structure in Redis. Essentially, it allows you to store objects in Redis, which is nice. So finding stuff in Redis is really the crux of what this talk is about. All right. How do we find stuff in Redis? Well, you can't just search for things in Redis, right? So this is a NoSQL database. So this operation here, select star from people where first name is equal to Steve, or select star from people where age is less than 35. It doesn't exist as a construct in Redis because it's a NoSQL database. There are modules that let you do SQL if you really wanted to, but we're not going to get into that at this talk. But essentially what you need to do for storing your objects is you need to build a secondary index. Now, what is a secondary index? It's an efficient way of finding items in the primary index. The Redis primary index is its keys, right? So this is, at the end of the day, it's a key value store. So the primary index in Redis is the key to actually get to something. Secondary indices need to be explicitly declared, and they may need to be separately maintained and updated. So they add a bit of a maintainability issue for the index in your database. Now, secondary indexes in what I like to call Redis vanilla, people often refer to it as Redis OSS, is something that can be built around the other data structures. And the reason I wanted to show you sets and sorted sets is that, like, you can do this stuff with these different data structures. So, like, if you want to do an exact text search, you can use a set. If you want to do an exact search for numerics, you can use a set. If you want to do any sort of ordered index, like you want to order people by their name, or you want to order people by their age, or something like that, you would need sorted sets. Full text search is also something that you can do, which is vanilla Redis, using sorted sets. And there's great articles about this, like doing all this stuff. But yeah, so like you have things like this set here, person:name, person:Steve, and you store the individual in there that matches that thing. Same thing with age, right? So you can store like the ID of the person as the member and the score as the actual age of the person. So this lets you actually build stuff out. So for exact matches, you would store your data in a hash. And then for each index name, :field, :value, you create a set, right? And then you query that set for the index name, :field, :value, and then you query the hashes that you get back from that result. And if you want to run more complicated queries, you can do that using the set operations that we saw before, like intersections and unions and all that kind of stuff. And then for ranges, you would use a sorted set, and then you would run range queries on the particular fields. I'll move on and actually look at Redis search. I want to actually sort of show you what this looks like if you're doing this in code, right? So I have this very basic person record right here. It has one operation, which is to send the whole record to a set of hash entries. And that's going to be used for inserting it into Redis. And then I have my test data set, which are the Muppets. I have Kermit, I have Beaker, and I have Bunsen. All right. And they all have a first name and last name, and I have a geolocation where they live, and an age, and a personal statement by each of them. And I'm only going to, for the purposes of this, index the first name, last name, and age. Because if we want to get into secondary indices, that's a whole nother, or secondary indices for like full text search or geolocks, that's a whole nother talk. But essentially, the first thing I need to do is actually connect to Redis. So I use, in this example, I'm using the Stack Exchange.Redis library and the RediSearch library, which I'll use later for the RediSearch stuff. And the Stack Exchange.Redis library, you connect to Redis through a single connection, and you initialize this thing called the connection multiplexer. So var connection multiplexer.connect, and I'm just connecting to localhost. And I have, for perspective, I'm running everything through Docker. So I just have this little Docker image called Redis Labs /redismon:preview, which I'm using for this talk. So you connect to Redis with this connect command, and then you get a database object. So db equals mux.getDatabase. All right. So with that database in hand, we can actually start performing operations in Redis. So the thing I'm going to first do is actually insert the items into Redis. So I have this method here that we use called add person OSS secondary index. So this is going to add the person to Redis, and it's going to create the secondary index for it. So I will say that the key name that I'm going to store it in is going to be person : I'm going to just, I'll just do good. And then I have to store it in Redis. So to store it in Redis, all I actually need to do is say db.hashset, as in the key name, which is the key name that I just created, and the hash set for it. So I just have, like I said, I have this little function to send everything to hash entries. So now it's actually in Redis, okay? So to create the index, I now need to set this thing up and set up all the indices in Redis. So I'm going to have 3. So var first name key name is going to be equal to person, name of person, : name of person dot first name, : name of person, or actually no, I don't need a name of it anymore. I just need p dot first name. So that's going to be the name of my first index. And so I can do a db dot set add, and I can pass in the key name for first name key name, and I could pass in the key name. Like I want to store essentially at this, in this thing, I want to store the person : some GUID, right? And it's going to be the same thing for the last name too. So I'll just last name. So same thing for the last name. I want to change that. And then for the age, the key name is actually a little simpler. For age index key name, and name of person dot age. And then I just do a sorted set add. So db dot sorted set add, and I will insert the key name at, well, I think I need a new sorted set entry array, and then I just create a new sorted set entry, and I pass in the element, which is the key name, and I pass in the age as a score. All right, after all that, I've created my person and I've updated the index that I'm inserting it in. So I can now go off and I can insert these all. So I could do an add person, passing a permit in my database, Do the same thing with Beaker. Do the same thing with Bunsen. All right, so after all that, we're all set up now to actually query things in Redis using the secondary index. So I can say what I actually need to do now is I need to look up things in here based off of their names, right? So if I wanted to look up all the Kermits in here, so all Kermits. So all the Muppets named Kermits. So I do equals db.sMembers, so set members. And then I pass in the key name that I'm looking for. So that's going to be person, first name, Kermit. Now, this is going to give me an array of strings that I can iterate through. Well, I think it's just Redis values, the result of this. So I can do for each in there. I can say, I now have to query the hash too. So db.hash get all, and I pass in the Muppets name or Muppets key name to string. And I can go through each record I get back from there. So Muppet hash. So this is a field now, and I can just print that. And run all this. You can see I got Kermit back. Cool. And now if I want to query all the Muppets that are under the, so Kermit is 66. So if I want to query all, went outside the method, sorry. I want to query all the Muppets that are less than 67, all right? Maybe they're not eligible to get their full Social Security yet, and we want to check with them. We now need to actually, instead of querying a set, now we just query the sorted set, sorted set range by score, and we start with person age, and then we pass in our stop, which is going to be 66, because that's inclusive. And then I just iterate over this, right? And, oh, you know what? I'm going to add a flush DB at the end here, so it flushes everything out. We're getting back multiple records. Hold on. So we have Kermit, and then for the Muppets named Kermit, and then the Muppets under 67 are all in here. Now the big problem is when we want to update something in Redis. So say Kermit just had a birthday, and we need to increase his age to 67. So we go in and we would do db.hashset. And we want to update Kermit. So the Kermit is Muppet in this case. So Muppet.toString. And we want to update their age to now with this in here, we want to actually not see him now in this list. So that secondary list where the Muppets are younger than 67, Kermit's no longer younger than 67, so he shouldn't be in here, but he's still in here. And the reason for that is that his age in the sorted set is still set here. So the solution to this is to actually go in and change Kermit's age in that sorted set. But the problem is that this is, so if I did db.sorted set increment, it might work. I could just do person : age and then up it. One. I think that might work. See, now he's no longer in here. And so you have to go in and you actually have to make sure you're always updating all of these and always updating them all the time. So this brings us to like our pros and cons of this approach. So the pro for this is that you could do this on any instance of Redis. So like any instance of Redis, I think sorted sets were introduced in Redis 1.2, which is 11 years old at this point. So that's been around for a while. All of these things have been around for a while, so you can do them anywhere. And they allow you to have total control over what you index and what you don't. And they're also excellent for job security because once you create these things, they're very complicated to do any sort of complex data modeling. You saw how long it took me to do everything and how complicated it was to actually build. And the biggest problem, I would actually argue, is that it's impossible to horizontally scale your database and maintain atomicity when you're updating data. And it needs to, you need to have regular consistency updates throughout any cluster that you're using. So Redis, when you're horizontally scaling it out, essentially all the keys that you're accessing might exist on different shards of your database. So the age set might exist on one shard, and like 3 of your records might exist on another shard, and 4 of your records might exist on another shard. And the issue is that if you want to update them, so like if you go in and you update Kermit's age to 67, you need to be able to guarantee that the age set is on the same server, is on the same shard as the Kermit hash, because if you want to do it atomically, it's not able to do that unless both keys are on the same shard. And you can do that. You can force things to the same shard, but that makes it, it sort of defeats the purpose of the horizontally scaling your database. Yeah. Anyway, so like that's the major disadvantages of this approach. It's complicated. You really need to think about how you're building things, and it's a big effort to undertake to actually maintain all this atomically and keep it going. And that brings us to RediSearch, which is another module. So similar to the JSON module, it's a module that's maintained by Redis, and it allows you to define a schema of an index and just create the index, and then Redis will just take care of indexing everything for you. And it automatically indexes your data. It provides, in addition to like exact match capabilities, it provides full text search capabilities. You can do geofiltering relatively easily. You can index things automatically, and those indices are maintained across your shards. And it operates under that same source available license I talked about a little earlier. So to run this, you can do Docker run. I'm using the Redis mod image, but there's a bunch of images out there you can use. But Redis Lab / RediSearch is the official canonical one for RediSearch for now. And creating indices is as simple as declaring an index on a type. You can declare them on a prefix too. So for example, you might only want to try indexing records with the key name that starts with person : indices contain a schema mapping fields to index types. So there's 4 index types in Redis right now, in RediSearch right now. There's tags, which allow you to do exact matches or faceted matches. Text, which lets you do full text search. Numeric, which allows you to index numeric fields. And geo, which allows you to index geolocation fields. So like if all the Muppets were going out to a restaurant, for example, like you want to see which ones of them live near that particular restaurant, you do that with a geo index. Querying, there's a relatively simple query language that comes along with this. It doesn't look like SQL at all, but it's not that difficult. Essentially, if you're looking at a particular field, you give it an @ symbol and you put the field name and a colon. And then for tag fields, you would just search within the braces, and that's your essentially all the text you're looking for. For text fields, you don't need those braces. For geo fields, you use a special geo filter, which I'll show you in a little bit. And for numerics, you use square brackets, and you give the lower and the upper bound that you're looking at. So I will show you what this looks like now in code. So I'm gonna delete all this stuff real quick. I'll delete up to here. So we created our database. The first thing you need to do, I'm using RediSearch, which if you go to github.com/stackexchange-redis, this is a separate library that's maintained separately by the Stack Exchange folks to handle the RediSearch stuff. But that's all centered around this client object. So a client, you set that to a new client, and you pass in the index name. So I'm going to call this index person IDX. You pass in the database object. And now with that client, you can create a schema. So I'm going to create a new schema. And for this example, I'm just going to spin it up every time because I'm flushing the database at the end, but you would just usually spin up your schema once whenever you need to change it. So you could do schema.add text field. And I'll just do, I'll make this a sortable text field. No, not sortable numeric. Text field. Last name. Do personal statement in here. I'm not be able to spell statement. Person.personal statement. Add geofield. Name of person.home location, and I'll just do the age too. Schema.add numeric field. Name of person.age. All right. So with that schema created, I can then tell the client to create the index. Create index. I can pass in my schema. I'll just pass in an empty set of these options. You could pass in the prefixes that you wanted to this thing too, but that's all you have to do to create the index. So the index is now created. And the next thing we need to do, I'll just go over how to insert things into Redis using RediSearch. So you have this person object in the database like we did before. And these first two lines of code, you create the key name and you add it to the set. You do that, and that's it. Now, after it's been inserted, Redis will automatically index everything. So you create a key name, you insert the hash, and you're up and running. So that's not too bad. So you do, what's this called? Add person RediSearch, and I'll pass in Kermit in the database. And I'll do the same thing with Beaker and Butson. So with these three in here now, I'll just show you how to actually do some of the same queries that we were doing before, and I'll actually show you how to do some more complicated queries too. So if I wanted to do, my first two queries were inline. Muppets named Kermit. So to find all the Muppets named Kermit, I will do a for each client.search, and I'll pass in a new query object, which will just take first name colon Kermit. I think I just have to get the documents from this. Get all those documents, and that each one of those documents is in here is the actual object. So console. And then you go through each field in the Muppet. I think it's the properties. So you go through for each property in there, and then you just do a console.writeLine field. So I just query the name that I'm looking for based off of that property, and I'm good to go. And so I got Kermit, the frog, each 66. He's a frog guitarist. And the next one was Muppets that are less than 67. And then I do the same thing. Except pass in negative inf to 66. Each parameter there. So there you go. We have Beaker. I actually don't know what Beaker's last name is, so I just put Meep in there. Bunsen and Kermit. So yeah, and then if I want to say hash set, and I pass in the Muppet .id, because this ID now is the key name, and I wanted to pass in the an age, and I want to set it to 67. 67, because you just run that again. Now you can see that the index is automatically updated and Kermit has been removed from here. So it automatically updates. I don't have to do anything else. So just update my data and I'm good to go. Moving on from that, if we want to run some more complicated queries, so like for the original secondary indices, I would have had to do like set unions, and all the sets would have had to be of the same type, or else I couldn't union them or intersect them. But if I want to just find all the Muppets named, if I want to find all the Muppets that are scientists, all right. So I have personal statements for each of these Muppets. Beaker is a humble lab assistant and scientist. Bunsen is a scientist and inventor. So if I want to find everybody who has scientists in their personal statement, I can actually do that. Muppets that are scientists. Now I could do the same query, except I really need to, for some reason, I'm drawing a blank on how to spell statement, and I really shouldn't be. But. So personal statement contains science. Okay, so if I want to search for all the people all the Muppets whose personal statement is scientist, I can do that. And we get Beaker and Bunsen. And if I want to look for all the folks that are guitarists, that includes Kermit, because that meme where Kermit is playing, I think it's actually a banjo. I said guitarist. Anyway, you can do stuff like that. And then like, you can also do really neat things like other really neat things like you can query things based on their geolocation too. So like, say, so I put all the Muppets in Hollywood because I think they shoot at Disney Studios in Hollywood, and let's say they all want to go to Nobu's in Hollywood. So I found ahead of this talk, I found the geolocation of Nobu's in Hollywood, and say the Muppets all wanted to get together and go out to dinner. I wanted to find all the Muppets within 20 miles of Nobu's. I can actually do that. And now this query object, I'll just create it outside of the thing. I'm going to create this first. This query is going to be a star, so that means anything. var2 equals new query. And then I can add a filter to this. So a new geofilter. And that geofilter is going to look at a particular field, which is going to be home location, this instance. And it's going to look at the latitude or longitude, longitude's first, very important, latitude, radius, and a unit. radius, like I said, is going to be 20, and the unit is going to be miles. And then I can use this same operation right here, except instead of that query being declared there, I'll just pass in my Q. And oh, look, they're all within 20 miles of Nobus. They can all get at the near Nobus. What if I wanted to change that to 5 miles, though? Maybe they're not all that close. Only Beaker and Bunsen are within 5 miles. So they want to go out to Nobus, and their restraint was 5 miles. They couldn't go out to Nobus and invite Kermit at the same time. Probably, I think he's probably the wealthiest of the Muppets, so he might be the one they wanted to pay. So who knows? But anyway, so yeah, that's querying with Redis, and that's building indexes and querying things in Redis. But to get back to our slides here, the other thing that you can do that's really neat with Redis search is you can actually run aggregations. So aggregations are you can essentially query data in a similar way to how you would query data otherwise with Redis search. It uses the same query language for their initial queries. But then you could build pipelines that actually transforms the data in Redis. Data that's indexed and loaded in the pipeline, that is. You can group like items together, and you can run reductions on them. And you can filter data based off of the results of those aggregations. So you can do all that. So an example of an aggregation that you can run is you can run an apply function. So you can apply a function to every record or every group in Redis. You can use a variety of mathematical string and timestamp functions on those things. And you can store the results of the apply function in the pipeline and use them later in the reductions and further apply functions and further reductions down the pipeline. Apply reductions allow you to group like fields together, and then group records can run reductions in them. So you can calculate summary statistics like a sum, an average, a standard deviation, and group records can be returned or passed further down the pipeline. So let's actually look at a little bit of this. So equals new aggregation builder. So I'll create this ag, which is new aggregation builder, and I can add an apply function to this. And the apply function takes a projection, like a predicate or something like that, and the alias that you want to store it in. So say if I want to have a relatively simple one. So I'll do format. I'll just do the first name and the last name together. So you do format. I need to pass in a format string. So single quote, %s, single quote. And then I can pass in first name and last name. And then I can just store this as the full name. I can just do that. And then I can just do for each client.aggregation or aggregate ag, and then I just pass and I just do get results. And then I can actually just do item, which is a dictionary. And you can see it actually pulled up the full names of each of the Muppets. Now, that's pretty neat. You could also, let's go back to this problem that we were looking at here, this geolocation issue or problem. So this lets you filter Muppets based off of their geolocation. It doesn't actually tell you how far they are. So if you wanted to get like a distance, you can also do that. So ag equals new aggregation builder. You can do an apply function, and your projection in this case would be geodistance. And you can pass in the home location, then oh, the coordinates for Nobu's, sorry. There we go. Just these two. I'll say distance to Nobu's. And one little finicky thing about Redis aggregations is that you need to make sure that items are loaded in the pipeline. So if something is sortable, it's automatically loaded in the pipeline. Otherwise, you have to call a load on it explicitly and pass in the field names that you want to load. So in this instance, I want to load home location. And yeah, so with this, I can then do another for each of this. And I'll just print this out instead. And this is actually printed out. This comes in meters. All right. So another neat thing that you can do with Redis aggregations. And then I think the final thing I'll do is show you like how to do like a group by and a reduction. Group equals and RediSearch aggregation. I think it's actually just Numeric. Yep. And then this, I think I just passed in new. Yeah, hold on. Yeah, so new list and then group by, you pass in, oh yeah, I think it needs to actually be a read-only collection of strings. A read-only collection of strings. Taking a new list of strings. I don't want to actually group anything because I want to calculate the summary statistics and everything, but you can just pass in whole thing. And then I need to pass in a reducer. So I'll do another new reducers. So reducers dot average age. So essentially, this is going to group all the Muppets together and just compute their average age. That's all it's going to do. Hit a breakpoint here. See what it store does. I think it just gives it an alias. There we go. That should be consistent. Oh. I didn't flush it. And yeah, so it calculates the average age, which is 51.3 for the 3 Muppets. Yeah. Anyway, and I did have a little preview of how I'm actually looking into making these things a little bit easier. I guess I might have just a little bit of time. Getting close. I wanted to answer questions if I could. I guess you'll all see in a couple weeks, I guess. All right. Anyway, I'm going to close out of this.
So far, right?
No questions so far. Oh, all right. So I guess I'll show you then. Assuming I can Oh no, did I just like? Yeah, so like, I mean, a lot of this stuff is, the query syntax can be a little counterintuitive. So something we're looking at doing is essentially allowing you to, build aggregations using like a Fluent API and do searches via Fluent API too, and do like declarative syntax for the objects that you want to store in Redis. So like essentially you declare an object and you give it a particular annotation or attribute, and you decorate all the fields you want indexed on that attribute. And then instead of creating something based off a schema, you create it based off type. And then, yeah, you can do searches. So like, get a collection of stuff. And you can do like items dot Susan or something like that, or just to make things a little bit easier, a little more intuitive. But yeah, I won't tease too much of that. I'll just get to the actual resources and sort of up. So yeah, anyway, just a little bit more about me. I'm Steve Lorello again. I'm a developer advocate at Redis. I've been a software developer for almost 8 years now. Almost all of the time I've spent working in .NET. Like Lee said at the beginning, I got my start working on air traffic control system, or not air traffic control system, GPS systems, and then I work on air traffic control, and then I go into like video conferencing and communications APIs, and now I'm at Redis. You can follow me on Twitter at @Lorello. Yeah. So some resources that I have for this, if you want to learn more about Redis and Redis commands, you can go to redis.io. If you want to learn more about Redis Search, you go to redissearch.io. This is a link to the Redis Docker image, and a link to Redis Search, which is the Stack Exchange library that I use for all this. And if you want to come check us out, you could. We have classes on Redis University that teaches you how to use Redis, and we're on Discord too. So yeah, I think that's all I have.
Awesome. Well, thank you so much.